everybody. This is the OMEGAMON Enhanced 3270 user interface webcast. Today we're going to talk about monitoring ZOS with the Enhanced 3270. Lawrence Hart, lead developer on OMEGAMON ZOS, will be our speaker. So, next chart. And so this is the newsletter. If you want to get at the ITSM newsletter, go to this link, sign up here. It's a nice way to keep up on all the things that are happening in the Z-Managed Tools area. Next. And for the enhancements, Enhanced 3270 user interface, all the playbacks, including this one, will be found at this link on the IBM Z channel under a playlist. So this will be 13, 14 webcasts out there covering all different areas. So with that, we'll get right to our topic today. Lawrence, take it away.
Hello, everybody. My name is Lawrence Hart. I'm in OMEGAMON for ZOS development. And this afternoon, I'm going to cover a range of topics related to the OMEGAMON for ZOS Enhanced 3270 UI. And basic format I'm going to follow is starting out by demonstrating some of the navigation, how one can get to Sysplex level metrics, followed by system or ElPro level metrics. And then maybe along the way and towards the end of the presentation, the latter part of the presentation, I'll be covering OMEGAMON for ZOS version 550 new features, and some of the features we've introduced in prior maintenance and releases. So anyway, getting into the navigation, here we're looking at all the active Sysplexes running in the enterprise. I'm going to use two different enterprises today. One is a performance and evaluation test system in Poughkeepsie, New York, and the other is a demo system that we use for our own purposes. And anyway, I'm starting out on the performance evaluation test system, and if I can draw your attention to the first column, if you can see my cursor, we're going to select, there's one Sysplex running on this enterprise. In fact, there's only one ElPro running in the Sysplex, but for demonstration purposes, it will suffice. If I want to look at the available navigations for this particular Sysplex, I can enter a / and hit Enter, and we will bring up an options menu. So I'm going to fairly quickly just give you an idea of what elements or features at Sysplex level are available. And I'll start out from the top of the menu, and we see option 1 there is report classes for Sysplex. Option 1, I'll select that, and here we see all of the report classes, or the active report classes on this particular Sysplex. Just basic information, the velocity, the kind of address spaces running in the report class, page rate, I/O rate, useful information, and we can select for the entire Sysplex all of the address spaces that are running in that report class across the Sysplex, with various metrics here, storage, CPU, everything you might expect related to the address space level, and that would show you address spaces across the entire system. So if I now back out, we covered report classes. Now, in OMEGAMON, we take two views at the one at the Sysplex level and one also at the complex level. So option 2 here is the enterprise CPC overview, and what we're going to see here is basically we'll see here that the complex we're running on, this is actually a Z14, which is why I wanted to use this system to demonstrate some of the new features in the 550 later on. And then basic information, the CPU percentage across the complex, the overhead, the weighting of all of the ElPros, number of physical engines that are running on the Z14, and then there are the 3 sub-panels here. I'm not going to get into all of the details, but this is really a complex level view of what we're monitoring enterprise-wise. We back out, and once again bring up the options menu. Some basic service definition data, just tells you what policy is running, when it was activated, and so on. I think we're getting the gist of just the fact that one can look at pretty much all of the metrics that one wants to look at the Sysplex level. We can look at global NQs. There are actually 2 here at the moment. We can dive in a little deeper. Those NQs are actually, they tend to be somewhat transient on the system, but if there are NQs that are holding out there for a long time or reserves, then one can monitor those and take action based on knowledge of the particular contention that's going on. But we will alert you to that contention through NQ and reserve summary. Once again, we go to the options menu, and we can look at coupling facility, very important part, obviously. By definition, the Sysplex has a coupling facility, and we supply many metrics on the coupling facility. Here we simply see the CF, but we have one coupling facility running, CF1. We have sub-options here. We can look at the coupling facility policy. Let's see, I'll show you that we show extensive information about structures in the coupling facility. We have further sub-options. We can look at statistics of both cache, list, and actually lock structures. And then if we look at the systems that are connected to the coupling facility, of course we only have one system running in the Sysplex, J80, but we can dive to the structure level and the system and look at the metrics for the systems that are connected to a coupling facility. I'm sorry. Okay. Resource groups. You can look at resource groups and the service classes. If we select a resource group, I just happen to know that there aren't any service classes defined for this particular resource group. But if there were, you would see service classes, and then the capacity limits of the resource group, its current utilization, and also the specialty engine utilization within that resource group, and the maximum percentage used for the resource group. Okay, the next selection is option 8. Here we look at the ElPro overview for Sysplex. Here we would see all of the ElPros running in the Sysplex. One interesting thing that one might want to do here is OMEGAMON for ZOS has near-term history. We can take a history option, historical summary for a CPC. So by entering an H, we can look at the history of this particular ElPro over a configured interval right now, and just to demonstrate something about near-term history, if we go to the top input line, type in V for view, and select I for history time span, we'll see that we're using one of 3 options here. Option 2, and option 2 will give us the historical, the last 8 hours. We could express what we wanted to see in terms of minutes, or a given time range, which is, in other words, you could go back to yesterday or even last week, but that would be contingent on you having RMF Monitor 3 data gatherers running on your systems in Sysplex, and having the archiving on those systems large enough to accommodate the RMF report data for the time period you want to look at. But you could define any time span within that archived data, or if it's actually cached in our OMEGAMON cache subsystem. For performance, we do cache certain or a subset of the reports that we use in our near-term history, and one can navigate to summary intervals that are contained in that cache, and that again is dependent on the size of the the cache and how many reports are contained in that, what time range of reports is contained in that cache. But anyway, we're looking at the last. I'm going to reduce this just for reporting. Performance is good on summaries, but 4 hours would be more normal. If you wanted to define 24 hours, that would be fine too. But just to demonstrate, we're now look at the last 4 hours, and this is for the ElPro. You can look at all of the CPU information. And in fact, I stand corrected. This is for the CPC. You can, we do have the options to look at the ElPro, but this is actually looking at the CPC over the last now 4 hours. And I'll show you the ElPro summary later on. Okay, option 9, storage resources, system, and sorry, I need to back up more to the Sysplex level. I apologize. We've looked at the ElPro overview, useful workspaces, top consumers. For the Sysplex, here we see several categories of metrics. Highest consuming address spaces of CPU, real storage, virtual storage, common storage, extended common storage, I/O, and here you basically see across the Sysplex the highest consuming address spaces, so one can maybe deep dive into an address space that's somewhere in Sysplex. You can look for an historical summary. If we look at option 6 here for the address space, so we'll be looking at the last 4 hours. In other words, if the percentage of the address space or the percentage of CPU that's being used is anomalous, then you might want to look at its history to see if this is a spike or there's been a consistent utilization that exceeds expectations over an extended period, and one can then investigate why that address space is consuming that amount of CPU, or even why it's running, for example. And the same with storage and I/O. So next, we can look at the service classes for Sysplex. In this particular case, we see all the service classes. They are sequenced in a descending sequence of performance index. We can look again at just how the service class has been doing over time, or service class period's been doing over time. So over the last 4 hours, this service class, we see that the performance index, there are warning indicators here saying that the performance index is exceeded. I believe the threshold is set at 1.4 for warning, and I believe it's probably 3 for critical. But anyway, you have basic information here about the transaction response times. If the subsystem that the service class represents actually reports those response times, you'll see them here. The service unit consumption and the actual performance of the service class against its goals. This is a velocity, and an indication here that I/O management is in effect, so the velocity includes I/O delays and usings, and the goal is that the velocity exceeds 70%. We're not, in these cases, obviously, we're not exceeding the velocity, and in fact, the velocity, the performance index is telling us that the velocity is actually at a level at which we consider a warning threshold and a critical threshold. So this service class isn't doing terribly well according to in meeting its goals, and that's probably why it's percolated to the top of the list or the default sequencing. We also show or provide metrics for XCF utilization, option 11 there. And in this particular case, we can select systems and paths from the Sysplex or XCF systems and paths. And here we see a pretty comprehensive view of all of the pathing between devices. Quite a few there. We have 138 paths, but take a look at that information. You can dive deeper, but I'm just basically demonstrating, giving you an idea of the metrics that are available at the Sysplex level. And the option 12, this is where we get to metrics that are specific to the ElPro level of reporting. So I'm going to go and look at those. So now for the image, and the image that we're going to look at is by by default J80, but if there are multiple images within the Sysplex, we'll see that when we get into these workspaces, one can, within a workspace, actually change the image that we're looking at in most cases, so we can see the metrics without moving out of the workspace for other systems in the Sysplex. So let's take a look at the address space overview. So this, as it suggests, as the name suggests, is a view of all of the address spaces running on the ElPro, and they're sequenced in descending order of CPU consumption. In this case, we have a DB2 address space that is consuming a fair amount of CPU. We can look at its history. There we see it's pretty much steady state. It's probably running normally, but it's consuming sort of about 2¼ engines worth of CPU. But there are other options we can look at for the address space. There are actions we can take, such as canceling the address space should it be a looping address space or for whatever reason shouldn't be running. One can cancel it directly from here. There is we can look at the bottlenecks, option 3 here. So this shows us all of the address spaces and the execution and delay states of each of these address spaces. They are actually sequenced by what we call the CPU loop index, which it's an interesting metric. The algorithms were developed over time to generate this particular metric. It gives you an indication, as its name might suggest, of whether an address space is looping or not. And what's actually useful about this is that if you have maybe a less important address space, or you have address spaces in your workload that may be looping, they may not show up that well because Workload Manager, with lower priority work, will allow that work to run, but because of its lower priority, other higher priority work will run ahead of it. But the problem is that this low priority work is actually using cycles and MSUs effectively that are, and there's a cost factor there. So they may be acting as what one used to call maybe a BAP soaker, a way of determining what the latent CPU, what latent CPU is available on an ElPro, but you probably don't want these address spaces running in a loop, and the loop index will hit 100 or very close to 100, and it's an indication that you may want to look at that address space and probably cancel it, get it out of the system. And then the other metrics here, the other columns, give you a view. There are, let's see, 33 different columns here, where we can see that there are a variety of execution await states, including crypto, locks, resource group capping, for example, and more importantly, where you're more likely to see metrics are in the area of the processors, IFAs or ZAPs, ZIPs, CPU weights, and then ZAP and ZIP weights, along with I/O. They are the heavy hitters usually when it comes to monitoring bottlenecks in an address space. Okay. I'll just go through some of these. Option 5 here, we can look at the storage usage by an address space. Here we see both common, real, and virtual storage metrics. We can also, I don't have time really to get into every single one of these options, but there is extensive reporting here. One can look at the execution of TCBs in the address space and detect down to the instruction level where an address space may be spending its time, can actually identify where a loop is if you have a mapping, a listing of a module or a program, and one can, in fact, this is something that I've used extensively in debugging my own code, but I won't get into that now. That's probably a whole session on how to use that. You can also look at TCB storage, LSQA, and the service class resources, and the historical summary for a particular address space. Okay, let's look at ZOS resources again. And we looked at bottlenecks. Enclaves. Here's something that we show extensively. Anything you want to know about the enclaves running on your system, we have very solid reporting on that. I know that on this particular, on this performance system, there are a lot of enclaves running, so it takes a little while to build the workspace. And we see there are over 13,000 enclaves, so the product handles that very well because, and also shows you extensive metrics of the CPU utilization, especially processor and general purpose processor. If we page to the right, we can see what type of enclave is running. We have dependent, independent, and we actually support work-dependent enclaves, which are extensions of independent enclaves. And they basically run with the same performance characteristics. A work-dependent enclave as an independent enclave, and we certainly will show you that. I think, here we go. Here's a work-dependent enclave. And we can actually take a look at it in more detail. Quite often they disappear. Oh, here we go. So we have all of the classification information and the related CPU information, both as a percentage and what's been consumed over the time the enclave has been active. And that's for any of those 13,000 that are running right now on this system. Looking again at the ElPro, we have extensive reporting on 4-hour rolling average MSU statistics. This is option 7. So this relates to defining ElPro group capacity, or actually capacity at the system level. So a group of ElPros or a single ElPro. In this particular case, we're not running an ElPro group, but if we were, we would have extensive metrics here on how the ElPro group, what its limit is, the percentage of capacity that's currently used, the MSUs that are used. The unused MSUs just gives an indication of what capacity is left. And at the ElPro level, we're currently just looking at the ElPro view of 4-hour rolling average. And we show the last 48 5-minute intervals in descending sequence of, chronologically. And we'll show how much time in each 5 minutes was spent being uncapped. That is, we haven't hit the capacity limit. And also if the percentage of ElPro capacity uncapped for each of those 5 minutes. And if one was running in an ElPro group, one would be able to determine just what percentage of the ElPro group in any 5-minute interval was consumed. So you can actually get an ElPro group view even though you're looking at the single image here. And basically, if an ElPro group capacity has been reached or exceeded, the unused group MSUs per hour goes to 0 or negative, and that's when ElPros start getting capped, and you start seeing percentage time capped and capped MSUs per hour and percentage ElPro capped statistics appearing. And also we augment the metrics in red to indicate that capping has occurred. And you can look back at a 5-minute granularity, so you may see spikes where, for whatever reason, capacity was exceeded for 1 or 2 intervals, and then the capacity returned to, the utilization returned to a level where the ElPro wasn't capped. And to help you with that, to determine what was running during a possible spike, one can look, if we look at option 2 here, at the interval CPU utilization by address space. So we can look at what address spaces were running during that 5-minute interval that we selected of the 48 intervals, and see if, what address space may have been contributing to the excessive CPU utilization. And here we see, obviously in descending CPU percentage sequence, the address spaces that are running. And obviously this system's running normally. It's not running. It's not capped. We didn't see any capping over the 5-minute intervals. But I'll leave your imagination do the rest. If you had a rogue started task out there running, maybe it was looping, shouldn't be there, using excessive CPU, you'd be able to pick it up out of the 48 intervals that are presented. Okay. Just looking through it, so you can look at operator alerts. Now we get to the first okay, sorry, I got distracted there. System and paging dataset activity. This gives us an opportunity to look at one of the new features that was introduced in version 550, and also one that was introduced relatively recently. System and page dataset activity. We have the regular system paging activity here, your auxiliary paging datasets, the DASB paging. We also will provide metrics, or do provide metrics for Flash Express, the storage class memory. Here we see a summary of the utilization of flash memory, the service times, and then basically everything you want to know about the 4K request, the 1 megabyte requests, some of the indicators that things were not working well, deferred page faults, deferred non-fault pages are indicators that you shouldn't see non-zero values there. So that would be an indication that flash memory is getting swamped by requests, overutilized maybe. But to get to the next level of flash memory reporting, one can place a cursor under the measurement interval literal here. And this is an example of a navigation called zoom navigation. Like I say, you put the cursor under the literal, hit enter, and this takes us to a new workspace. And this was actually developed over 2 releases. Initially, OMEGAMON provided a view of the address space level view of flash memory utilization. And in terms of the 4K and 1 megabyte requests, writes and reads and pages, and if we page to the right, the total number of blocks, storage class memory blocks that are in use. There's not much utilization of flash memory obviously going on here right now. But what was introduced, this was introduced pre-550, but in version 550, we made this workspace a tab workspace, and if one selects the SCM cards tab, what we see here is actually specific to the Z14 and introduced in the Z14. VFM is virtual flash memory. It actually represents memory, flash memory, which is now in the processor memory drawer, no longer resident on a PCIe card. Previously, prior to the Z14, flash memory was supported by a pair of PCIe cards or multiple pairs of PCIe cards. And I'll show you a little later on our other demo system, which is not running on a Z14, that one one would normally see two rows here, one per card. And in the case of virtual flash memory, we only see one row. The top sub-panel here is showing us the extended asynchronous data mover statistics. This is how data moves between the memory drawer and central, the processor memory, or in the case of PCIe cards, between the PCIe cards and processor memory. And these have the typical metrics one would expect for that kind of movement, I/O statistics. Okay, this is the first case of near-term history. Of this new support, there is an option to look at history for the SDM card, and if we select that, we see that we have numerous metrics here, both by the ElPro at the ElPro level and at the complex level. So the utilization, the bytes read, the bytes written, and the requests, the average response times, just at the CPC level, the complex level, the IOP queuing time, and then the numbers of requests. Not much going on in this ElPro, but across the complex, we see that there are sporadic spikes in the numbers of requests, quite large numbers of requests. If one wanted to look at a particular row or a particular interval, these are 5-minute intervals, by the way. That's our near-term history. It's grouped into a 5-minute level of granularity. And furthermore, I should add that our near-term history is all based on RMF monitor 3. The RMF data gatherers in each image report to the RMF distributed data server. OMEGAMON communicates with the RMF distributed data server for the reports that we utilize for near-term history, and for actually for some of our real-time data. But if you wanted to look at a selected interval in portrait format, there's more convenience. They do paging left and right. Again, this is typical of our near-term history reporting. If you have a lot of metrics in a row, it's sometimes more convenient to look at those metrics in this, what I call portrait format. If I draw your attention to the bottom of the workspace here, one can navigate chronologically, horizontally, back and forth within the summary interval. So if I just put my cursor on 1505 there, we're looking at the interval that ended at 1500 right now. So if we wanted to look at the interval that ended at 1505, we're now at that interval, and so on. Just keep hitting enter with our cursor in that position, and eventually we see here that there's nothing earlier. So if we page backwards, if we look at the metrics, we can see them changing. This particular report is cached, so the response time is pretty good. So backing out of there, that covers our flash summary, our flash memory support. Let's take a look at some more ElPro level resources. If we look at, let's see, active DASD devices, you can get all of the metrics one would expect related to your DASD phone. One thing one can do with each device, you can, again, navigate to a near-term history for a specific device. And in this case, there are only two intervals where the device is active. But if you have an active device over time, or a device that is overutilized, then you might want to investigate, and so one can look at the jobs that are during the interval that were accessing the device. And as we can see, there's only one job here that was accessing the device, but you might identify workloads or jobs that are accessing a device that shouldn't actually be in there contending for use of a device, and so it allows you to determine whether or not you want to either suspend a job or cancel a job because it is detrimentally affecting the I/O access of jobs, of your production jobs or lot-one workloads. Okay. I think I've covered pretty much the basic navigation at the Sysplex level and given a good idea of how you get to the ElPro level. Now I want to focus on a few of the features that were introduced in recent releases and maintenance. I'm going to start with system CPU utilization, which is option 4 at the ElPro level. And looking at this, this tells you everything you need to know about, the CPU, that is general processor or standard processor, zip and zap. Utilization tells you the relative processor speeds, the zips and zaps and CPUs that are online. But what I'm more interested in showing you is are some options here. The OMEGAMON for ZOS supports hyper-dispatch specific metrics and the more recent multi-threading or the FMT or simultaneous multi-threading metrics. So I'll start with hyper-dispatch. And here we see a 3 sub-panel workspace, basic information. Obviously, hyper-dispatch management is on. In fact, it now has to be on recent processors, but it's on prior levels of hardware. One could selectively switch hyper-dispatch on and off. The ElPro cluster that the ElPro lives in. And then 2 categories of processor here, standard and zip. If you have an older processor that actually supports ZAPs, which is pre-Z13, we'll show you the Intelligent Resource Director weightings. The MVS, it's affectionately known to anybody in ZOS, the MVS percentage utilization is the operating system view of logical processor utilization versus the next metric, which is the physical processor utilization. So this reflects the utilization of the logical processor when the ElPro is actually dispatched to physical processors, whereas this is a metric that provides a percentage of the actual physical processors that is being utilized. Now, at the individual processor level, we see these hyper-dispatch specific metrics, the concept of high, medium, and low processor priorities. The share percentage of highs is always 100%, and then based on the ElPro weighting versus all the other shared ElPros in this Sysplex. There's a so-called medium weighting that's, in this case, 56.3. Low is always at 0. We have the physical CPU percentage, the ElPro management percentage, again, the operating system view of the logical processor utilization. These processors have not been parked. High processors and medium processors are not parked. That is exclusive to low priority processors. And in this case, the utilization has not hit a level at which these low utilization processors, and I'll just page down a little here. I can use the row entry, and here now we see that there are in fact 4 low priority processors. They're all parked, but if this was a heavily used ElPro, these low priority processors would get unparked and parked periodically, reparked periodically as the load shared amongst the high and medium priority processors exceeded a level at which they could handle efficiently, and so the low processors get unparked and capacity gets sort of added to the group. If we page down a little, we'll now see the processes here. And unfortunately, and I noticed this earlier, is that this actually, with this delineation, we're now looking at zip logical processes. If I page back, we're looking at standard logical processes. There are no ZAP logical processes, so they would show up. But what I wanted to draw your attention to was that you have the same metrics for the zips, but because this ElPro is running multi-threaded, it's running MT2, 2 threads, which is supported only for zips on the Z14 and Z13. We actually see metrics for thread 0 and thread 1. So for a physical core, which in this case is core 2.0, we're seeing core level metrics, the hyperdispatch share, the physical CPU percentage management, the ElPro management percentage at the processor level. But for the operating system view of logical process utilization, effectively each thread is a logical CPU. So we see CPU percentages for each thread that represent, and these represent logical processes. And the same applies to the parked metric. That's available for both threads, whereas these metrics to the left here are purely at the, it's not just thread 0, they're at the core, what we call the core level in the multi-threading environment. So just backing up, I'll show you the multi-threading specific support. So in this case, it's really an extension of the hyper-dispatch support. But here we start talking about, as I was mentioning earlier, cores versus CPUs, physical CPUs. We call the differentiation in definition here is that a core can contain one or more threads which run through it. So we're looking at cores. There are 52, but some of those cores can run multiple threads. And the total threads across these processes happens to be 72 threads. The measurement interval is just telling us over what interval the metrics in the subpanels below represent. And here we see some terminology which is specific to multi-threading. The mode, 1 indicates single threading, 2 indicates MT2 or 2 threads to a physical processor. The capacity factor, maximum, is an indication that what the maximum ratio of threads to, or thread processing to on the physical processor is, and 1.477, that's actually a capacity factor maximum that is quite high. When multi-threading was first introduced, 1.4 was considered, the sweet spot for multi-threading. If you could achieve a maximum of that, then that was considered, high. I think on the Z14, I have a feeling that things were improved, and maybe you'll see maximums exceeding that. We're certainly seeing it here. So that's the maximum that could be achieved by logical threads. But the actual capacity factor achieved on these zips is 1.2. So there are many factors that can remember. So 2 threads running, one might think, well, capacity factor maximum could be 2, but the reality is that because threads can both be running and then they can basically interfere with each other. One thread can cause another thread to wait by, for example, going off and trying to resolve a processor cache miss. During that time, then the thread is waiting for the cache miss to be resolved, and that means that the logical processor or thread is not able to run, so that reduces the capacity factor maximum. And then within that capacity factor maximum, the factor achieved is going to be some percentage of the maximum. And that's reflected in if we go over to the right, the multi-threading productivity percentage, that's basically the capacity factor achieved divided by the maximum. And the multi-threading utilization percentage is actually a function of the ElPro busy percentage. And here we see for the zips of the physical processor, the core utilization is 22.4%. And if we take the multi-threading productivity, multiply the core busy percentage by that, the productivity, we end up with what's known as the multi-threading utilization. And we show that for every processor. If we look here, we have all the standard CPs. They're not multi-threading, so their productivity is always going to be 100%. But if we get down to the zips, we see the same thing as we saw with hyperdispatch. We see these metrics. We see again, the operating system view of the thread utilization or logical processor utilization. And that, I think, I've covered as much as I want to. Okay, so backing up, I'm going to take the default navigation. Simply have to put the cursor next to the Sysplex name, hit Enter, and this would the ElPro overview for Sysplex will present all of the ElPros running in the Sysplex. And the default here is to look at all address space. Look in the ElPro. But what I want to focus on here is another new feature that was introduced in version 550, and that's PCIe devices. So we take that option, we get to a multi-tabbed workspace, and we support 4 major devices, and along with hardware accelerators and a catch-all, which is called Other. The default navigation will bring up RoCE, that's RDMA, or the Converged Internet, so it's sort of shared memory across platforms. And here we see basically that each of these functions that are associated with PCIe we'll see that this is common to all of the PCIe device types. You'll also see a channel ID and the device type. In this case, we're RoCE Express 2. There are other versions of RoCE that can appear here. The job name that owns the function, it's ASID, and then statistics that are specific to RoCE. There are 4 in this case: transfer, read rate, write rate, and the packet received and transmitted rates. Not a lot going on, but one thing I'll demo here is that you can look similarly to the flash memory support. One can look at near-term history, the specific, metrics to RoCE. Nothing's really appearing here. There's very little activity, but the PCIe card itself was active, and we see here there are common PCI load, store block, and refresh metrics that are common to all of the PCIe devices, except for Z hyperwrite, which we'll see later. So, and if we page over to the right, we can see the date that the device is allocated, the time is allocated, over the interval, what percentage of the time was it allocated, and the number of direct memory access address spaces. The address spaces are there for the purpose of transferring directly from the PCIe card to memory on the operating system without the processor having to intervene. It's an efficient way of moving data between the device and core memory. Okay, and again, if we select any interval, we can look at the portrait version of a row. A lot of metrics here. More convenient to look at an interval this way maybe than paging back and forth across a row with all of the navigation options. Okay, backing up, we can look at ZEDC. This is IBM's compression feature on Z. And here, same metrics again, up to the point where we get the specific metrics. Here we get the work unit rate, the adapter utilization percentage, not heavy utilization here. We tend to start getting, not concerned, but interested at 40%, and concerned maybe at 60% are the rules of thumb. We get the application compression, request rates, decompression. It's all about compression, decompression, the throughput rates, the ratios, the buffer memory size, the utilization of the buffer pool, the hardware accelerator time busy percentage, transfer, read and write rates, execution time, queue time, request size, standard deviations for the queue time and execution time, the type of accelerator, and then we get to the common, the actual card metrics. If I take the default option of navigation, we get the same view of all these columns historically over this time period. I think I set it to 4 hours. You can set it as you need, and we've got a lot of metrics here. So if I select one interval, you can see all the metrics in one file swoop and page back and forth between them. The next device type is C hyperlink. DB2 logging required. Synchronous I/O was the working name for C hyperlink. DB2 logging cannot withstand asynchronous I/Os because of the transaction rates. There's a huge component. I/O was becoming a huge component of the logging. So C hyperlink came along, and here we see there are 4 function IDs, all allocated by the I/O SAS address space. But we have a myriad of metrics here, and I'm going to page quickly through them. But again, we see metrics at the ElPro level and at the complex level. As we move across, there are request rates, read rates, read ratios, write rates, write ratio, and we'll also see that, and I apologize, there's an upcoming PTF which will resolve. There's some issues that we only saw post-GA with the hyperlink. The link port ID is fine, but the serial number and the type model, these are invalid right now. And I think the utilization earlier, but that's resolved in the PTF that we're about to release. Okay, again, you can look at the history of all of this, and if you want to see all of these, you see that the device was deallocated here and reallocated, so that's something one might be interested in seeing. What happened during this time period at 12:55 or 12:45 to 12:55. But all these metrics, again, you can see in portrait format. And finally, we have internal shared memory. It's sort of the Rocky, but ElPro to ElPro, if you like. It's memory to memory in the same box, but across ElPros. And not too many metrics here. Basically, you're looking at the physical network port and the transfer write rate of all of the other common metrics for the PCIe card, history, and portrait format. And with that, I'd like to wrap up, and thank you very much for the time you spent.
Lawrence, a couple questions.
Yes.
The memory objects, did we show the memory objects where to get to?
Yeah, I can certainly show that.
Yep.
Okay, so I'll extend this a little. I apologize. That's something that's okay. Now, memory objects, we have extensive support for 64-bit memory, 1 megabyte pages, and even 2 gigabyte pages. We introduced that support in version 550. We have some metrics for that. And if we look, I'll go with the history option because we can look at these metrics over time. And here I'm looking at history for the CPC. If I select an interval, I can look at J80. That's the ElPro that we are working with on this particular Sysplex. And I can take options here. One of the options is to look at details or an historical summary for the ElPro. So if I look at an historical summary, we see all the various metrics there, but we're interested in memory objects, and so we have an option here to look at option 2, historical address spaces in an ElPro. So at the address space level, we now have a workspace that is a tabbed workspace, and when it pops up, okay, here we go. Now, by default, we're going to look at CPU for an address space, but if we look across the top here, we see 3 extra tabs, real storage, common storage, and what we want to focus on is the memory objects tab. And so here we see all of the address spaces that are running that have allocated memory objects, and the workspace is presented by default in descending numbers of the average memory objects allocated. We show the average memory objects for high virtual common, shared, and private. The memory objects backed by 1 megabyte frames, fixed frames, average 1 megabyte frames. If we page to the right, we'll see the various metrics you see, the average storage, then pages backed in central, average high virtual common, high virtual shared, high virtual private, high watermark for common, and then high virtual shared memory objects backed by 1 megabyte frames. So a whole slew of metrics here that are related to 1 megabyte pages and memory objects, and we'll see a couple of 2 gigabyte columns over to the right. Oh, sorry, I went the wrong way. So here we see these are showing up as unavailable because this system is not supporting 2 gigabyte frames right now, but in fact, another thing I have to say about this is that this system does support 2 gigabyte frames. It just so happens that the level of RMF maintenance on this system is back-leveled, which is surprising, but it actually is. And so at the address space level, these metrics are not being returned by RMF. But if one were, the support was there from RMF or at the right maintenance level, we would see these 4 metrics here that would not be showing up as unavailable. I'll also add that we see some large numbers here. The PTF that I just mentioned resolves seeing these large numbers. We use suffices, which is what one expects of megabyte, gigabyte, terabyte. So it's a much more visually pleasing display that one would see. Now, I can demonstrate. There's one other thing I wanted in terms of memory objects and 1 megabyte pages. We can. I go to history, and look, here's something that's interesting that I haven't shown. It's a feature of the product. We can look at all of the delays, the address space delays across the entire Sysplex. So these address spaces, if we're actually looking here, it just so happens it's a characteristic of this support that we can look at other ElPros outside the Sysplex. Normally, in a production environment, all of the ElPros in the Sysplex would have OMEGAMON running on them and be reporting back to our hub TEMs. But here we see that these address spaces are running on a variety of systems. At the top here, we see the total delay percentage, that's the sequencing, and then a variety of categories. But if we wanted to look at this particular address space, we can look at address space details, and I haven't got time to go into all of the options, but if we look at the details, what we'll see is that we have the execution of delay states, and let's see, I'm looking for, in this particular case, I just want to get to, I'm not seeing what I really wanted to show everybody here. Okay, hang on. I'll look at summary for an address space. The metrics I'm trying to get to are for memory objects across the entire system. So, let's have a look. Isn't it? along here. Okay, so here we can look at historical address space details. This is the one I want. This will be the last workspace that I'm going to demonstrate. So when we get to the details, this shows us various categories of information. The CPU used at this point, it doesn't look like this. Actually, there are problems obviously getting to that. And when we see query timed out, particularly you see the CPU used by the address space here. But what I want to show you is that the memory objects allocated, this is highlighted in white, and that means one can zoom by pressing the cursor and putting the cursor under the literal and hitting enter. We'll get to the next workspace. This is a test system, and the response time is, they could be doing stress testing right now. But what I wanted to show you was that there are 2 GB memory object metrics here, and the metrics, again, the RMF maintenance, while previously it looked like they weren't there are 4 metrics here for 2 GB, and a couple of the metrics here are not being returned properly. I've been working on this and actually talked to the RMF group about this, but you will see 2 GB metrics here with the appropriate level of RMF maintenance on 550.
Well, that's excellent, Lawrence.
Okay.
I think that's about it, right?
Yeah, that's as much as a lot more I could cover, obviously, but I think my time is up, and thank you for taking the time to attend this presentation. It's been my pleasure.
Okay, thanks.